Okay, today's lesson is about how to find the determinant of a 3 by 3 matrix, and we are going to do it two different ways. We're going to use something called cofactor expansion, which is also called using minors, and then later we will also find the determinant using diagonals. But let's start off with cofactor expansion, or minors. And here's how it works. First thing you do is pick a row. Alright, you pick a row that you're going to use to do this process. I recommend picking a row that has the smallest numbers and the numbers that are closest to 0. Smallest in absolute value, if you will. And if there are any zeros, that's even better. So for example, I'm going to go ahead and use the middle row. These numbers look pretty small, and I like the fact that there's a 0 there. So I've picked this row, and the way it works is each one of these numbers is going to become a multiplier. So I'm going to have 4 times, and then I'm going to put a matrix in here, and these lines indicate that I'm going to be doing the determinant of that matrix. But we'll come back to that in a second. I'm doing 4 times something, and then I'm going to do 0 times something, 0 times a determinant, and let me change colors one more time, and I'm going to do 2 times a determinant. Okay, so each one of these numbers in the row, each one of these entries is going to become a multiplier. Now, before I tell you how to get the matrix that we put in here that we'll take the determinant of, you have to be careful of the signs of each one of these multipliers. Now, the signs depend on which row you're in. Because we're using this row, then these will be the signs. It will be like negative, positive, negative. Now remember, when you see negative, you should be thinking opposite of. When you see positive, you should be thinking, well, that's going to stay the same. Because I'm saying negative, but if this 4 had been a negative already, negative 4 is positive 4. So really, you should think opposite every time you see a negative here. And the positives mean that it will stay whatever it is. Okay, so it's like opposite, same, opposite. So in this case, the 4 should be opposite. The 0 doesn't really matter because it's 0. And the 2 will be opposite. So it's like opposite, same, opposite. So just be careful of that. So the 4 is going to actually become a negative 4 because of the opposite right there. Just to be consistent, I'll go ahead and put a plus 0 because of the plus there. And then the 2 will also become opposite because of the minus. Okay, if we had used the top row, then we would have used the plus, minus, plus. Same, opposite, same. If we used the bottom row, then we would have done plus, minus, plus. Same, opposite, same. Alright, but back to what actually happened. So now, here's how you find what goes inside what matrix we actually multiply and take the determinant of. Well, since we're taking this one at a time, starting with the 4, focus on the 4. That was the original multiplier, and we've already basically crossed out this row with this highlighting that I've done. But let's also go ahead and cross out the column that we're dealing with here. Okay, so since we're dealing with the 4 is the first multiplier, we will cross out not only the row, the second row, but also the first column. If I cross those out, then look what is left. I have negative 1, 3, negative 2, and negative 5. Now this matrix is known as a minor. That's why this is called using minors. Okay, and that's how you get it. When we move on to the 0, then you cross out the 0 column. And then you look at the numbers that are left, which in this case are 5, 3, 1, and negative 5. All right, and then we move on to the 2 column. I mean, it came from the 2. We had to do the opposite, but the 2 column, and we cross that out. All right, if we cross out that 3rd column, then you see that the remaining minor matrix is 5, negative 1, 1, negative 2. All right, so all we have to do is take the determinant of each one of these minor matrices and multiply by the multiplier. Now, let's go ahead and deal with this. This is why I like 0 so much, is because 0 times anything is just 0. So we can forget about this middle term, it's gone. Now, please remember as we do the determinant that the way you calculate a determinant, so I've got this negative 4 times something. Now we're supposed to do the determinant. The determinant is the down diagonal minus the up diagonal. Okay, down diagonal minus the up diagonal. Okay, so the down diagonal here is negative 1 times negative 5. So that's positive 5 minus, okay? Now the up diagonal is negative 2 times 3, so that's negative 6. So I have 5 minus negative 6. Down diagonal minus up diagonal. All right, so obviously that'll turn positive. We'll deal with that later. Now this is gone because it's 0, so we can skip that for now and get on over to this one. So this will be negative 2 times. And again, we're going to do our down diagonal minus the up diagonal. Okay, so the down diagonal is negative 10. We're multiplying. Minus the up diagonal is negative 1. So we have a lot of minus negative going on. So let's go ahead and finish this off. So I'm just going to switch to a neutral color like black. Or maybe I shouldn't. I'm just being lazy. Let me not be lazy. So this is going to make negative 4 times. Okay? Now remember, 5 minus negative 6 is the same thing as 5 plus 6. So that's going to be 11. Okay, and then over here, same type of thing. Alright, this is like negative 10 plus 1. So that's going to be negative 9. Alright, minus and negative is addition. So that's negative 9. So I'm running out of space. Maybe I can put it over here. So that's going to give me, alright, negative 4 times 11, that's negative 44. And then negative 2 times negative 9, that's positive 18. Okay, so negative 44 plus 18, that is negative 26, so that is the answer. Okay, so that is the answer to problem number 1. It's negative 26. All right, let us do that again with problem number 2. All right, again, I look through and I'm looking for which number seems smallest, and again, I'm liking the middle column on this one, mostly because it has that 0 in there that allows me to just throw things out. So let's start with this. Now, so the 0. So here we go. So I'm going to have the 0 as a multiplier. Okay, and then I'm going to have my matrix. Alright, and then I'm going to have the 1 as a multiplier. Okay, and then I'm going to have my matrix. Okay, and then I'm going to have my negative 4 as a multiplier, and then I'm going to have my matrix. Okay, before I do anything else, all right, the 0, the 1, the -4. There's my 0, my 1, and my -4. Check the signs. The first and the last have to be made opposites of what they are. The middle one can stay what it is. All right, that's what these symbols mean. So negative signs, take it to mean opposite. So 0, it doesn't really matter because the opposite of 0 is still 0. But this is going to matter. So this -4 is going to switch to a +4. Okay, because of this. All right, and this gets to stay the same. Now we can do the matrices. All right, so let's do the 0 first. This goes away. Okay, so we're going to have 2, 9, -1, 2. So it's 2, 9, -1, and 2. All right, now let's do the 1, the middle. That leaves 3, 9, 5, 2. So that's 3, 9, 5, 2. All right, now let's do the 4, or the -4. Okay, that's this one. And that's going to leave behind 3, 2, 5, -1. So 3, 2, 5, -1. Okay, so now it's time to simplify all this stuff. I like that first one with the 0, that's why I picked it. Alright, 0 times anything is 0, so I can forget about that term. Okay, so that leaves me with this one. So this is going to be 1 times something. Remember, it's down diagonal minus up diagonal, so that is 6 minus 45. Okay, and then I've got plus 4 times down diagonal minus up diagonal. So that's -3 minus 10. Okay, all right, so you're just going to crank all this out. You're like, really, you don't have to do this all in pieces. Once you have it set up like this, you can just go ahead to the answer. Just to make a point, I'm going to type all this into the calculator exactly the way it looks. If you're very comfortable with working with integers, you could certainly continue on and do this in pieces, but however you do it, make sure you get the correct answer. But I'm going to type this all into the calculator right now. Alright, so I really could just type all this into my calculator. I even typed in the 1, which is really not necessary. Okay, but either way, you should be getting -91. Okay, so from now on, once I get to this point, I'm just going to skip to the answer, and I'm going to trust that you could either subtract and you can figure it out the rest on your own, and if you have any trouble with it, you can always just type it all into your TI-30XS multi-view. Alright, let's move on to the third problem. This is the last one that we're going to do by cofactor expansion. Alright, I almost want to get some variety going, but I can't help the fact that once again the smallest numbers and the 0 are in the middle column. So I really am going to go ahead and just stick with the middle column on this one. But please understand that if these zeros and things had been in another row, like if they'd been in the first row, for example, then the only thing I would have to adjust is the signs. Okay, and instead of doing negate, keep, negate, if I were doing any other row than the middle, I would do keep, negate, keep. Okay, but as it is, once again, I'm going to wind up doing negate, keep the same, negate. Alrighty then, so as I've done twice now before, I'm going to do the 0 with a determinant, and then I'm going to do the 1 with a determinant, and then I will do a 3 with a determinant. Now remember the signs, it should be negate, keep, negate according to this pattern right here. And I'm on the middle row, negate, keep, negate. So that means, you know, 0, negate 0, you still get 0. I'll just do it just for fun. So negate, keep, negate. So this is going to actually become a -3. Alright, but let's on with the rest of it. Okay, so I'm looking at the 0 and I'm thinking, okay, I'm going to take out that column. So that leaves 15, 2, 12, and 2. Now let's move over to the 1. Okay, if I take those out, that leaves 1, 2, 2, 2. Okay, that's pretty a nice small numbers. And then let's do the third column. Okay, take out the third column, and that's going to leave 1, 15, 2, 12. So 1, 15, 2, and 12. Alright, so once again, this one multiplying anything by 0 is just 0, so boom, that's gone. So now I can concentrate on the other 2. So this is going to be 1 times, alright, and remember this means we're doing the determinant, so that's down diagonal minus up diagonal. So that's 2 minus 4. Okay, and then meanwhile over here, we're doing, I could put plus -3, or I could just put -3 is better. And again, I'm doing the determinant, so down diagonal minus up diagonal. So 12 minus 30. Okay? And you can work it all out by doing this minus that. But either way, you should be able to come up with the final answer that matches mine. Worst case scenario, you can type it into the calculator. So you should be coming up with 52. Alright, and that is the answer to number 3. Okay, now it's time to learn the other method of evaluating, finding the determinant of a 3 by 3 matrix. And this method involves using diagonals. Remember, every time we were finding, every time we did the determinant with the 2 by 2 matrix, we always did the down diagonal minus the up diagonal. So that's how we would get 5 minus -6. Alright, keep that in mind, down diagonal minus up diagonal, because we really are just going to extend that process to somehow do with a 3 by 3 matrix. Here's the first step. The first step is to recopy the first 2 columns over again out here. So this is going to become 2 and 0 and 0 and 0 and -5 and 0. See, I just recopied the first 2 columns. Now remember what I was talking about, down diagonal minus up diagonal? Now what we've just created, the reason why we did all that copying is so we could make 3 full down diagonals. Okay, so there are our down diagonals. So the way this process works is we're going to do down diagonals minus up diagonals. Alright? Just like we did when it was a 2 by 2, when we did down diagonal minus up diagonal. But this time we will have 3 down diagonals and 3 up diagonals. All right, so let's start with our down diagonals. So the down diagonals are, okay, I've got 2 times -5 times -2. Well, negative times a negative is a positive. So -5 times -2 is 10. So I've got 10 times 2, so that's 20. So that's my first down diagonal. Then my next down diagonal, well, I see those zeros, so that's +0. Now my third down diagonal, again with the zeros. So down diagonals, 20, 0, 0. Minus, now we have to do the same thing with the up diagonals. All right, and the up diagonals are like this. Here's 1, here's 1, and here's 1. All right, there are 3 up diagonals. Now look, 0 times anything is 0, so that first up diagonal is 0. If you see 1 0 in it, it's going to be 0. Second up diagonal, there's another 0. Third up diagonal, again with the zeros. All right, so really the only thing that's really here is a 20. So that's just going to turn out to be 20. Okay, so boom, that would be the determinant of this first matrix. And I am going to require you to show this work, okay? You can go straight from here to the answer, but I at least need to see your 3. I want to see your 3 down diagonals minus your 3 up diagonals in parentheses. All right, let's do that again. I think I will switch colors. All right, just so we don't get mixed up. So what did I say to do first? Recopy the first 2 columns. So this is going to be, why did I do that? This is going to be 6, 4, -2, and then 1, -2, 4. All right, I've just recopied the first 2 columns. So I'm supposed to do down diagonals minus up diagonals. So here we go. Down diagonal, down diagonal, down diagonal. All right, so my down diagonals are going to be like this. All right, I'm doing down diagonals minus up diagonals. So, all right, so I've got, look, 2 times 3 is 6. So I've got -6 times +6. So that's going to be a -36. All right, 6 times 6 is 36. The second one, I see that 0 is in there, so that's just going to be 0. The third one, all right, I've got -2 times 4, so that's -8. -8 times 4 is -32. All right, so I've got -32. Okay, so that's my 3 down diagonals. Pardon my yawn. Can't help it. Now I'm going to do my 3 up diagonals, and so I can subtract. So here's an up diagonal, and there's another one, and there is another one. Okay. Okay, 2 times 2 is 4. All right, so -2 times -2 is +4. Times -2 is -8. The second up diagonal has a 0 in it, so that's just going to be 0. And then the third is 3 times 4 is 12 times 1, so that's just going to be 12. All right, I trust that you could work this out by hand, and if you can't, there's always the calculator. All right, either way, you should be getting -72. All right, so this is how you find the determinant of a 3 by 3 matrix using diagonals. Let's do one last example. I think I'll switch to purple. Copying down those first two columns so that I'll have 7, 3, -6, and then I will have -2, -1, and 2. Okay. I was a little crooked, whatever. I think it'll be fine. So I'm going to do my down diagonals once again, all right, minus my up diagonals. So let's illustrate it like this. Down diagonals are this guy, and this guy. And then my up diagonals are this guy, and this guy. Okay, so here we go. Down diagonals first. 7 times 4 is 28. Times -1 is -28. Okay, let's see. -2 times 5 is -10. -10 times -6 is +60. Negative times negative is positive. And then finally, let's see, I'll do it this way. 3 times 2 is 6. And then 6 times 6 is 36. So that's +36. So that's my down diagonals. Now my up diagonals. 6 times -6 is -36. Times -1 becomes a +36. Okay, so that's my first up diagonal. Now my second one. 2 times 5 is 10. Times 7 is 70. So that's +70. Now my last up diagonal. Alright, I'm going to do it this way. No, I'll do it this way. 4 times 3 is 12. 12 times -2 is -24. Okay, so this is what we've got, my friends. Alright, so this is 68 minus 82. So that's going to be -14. Alright, so that is going to be the determinant of this 3x3 matrix. So now I have shown you two different methods for finding the determinant of a 3x3 matrix. First, I showed you that you could find the determinant using something called cofactor expansion, which is also known as using minors. And remember, we had to pay attention carefully to the signs depending on which row you picked. I happened to pick the middle row in all of my examples, and depending on which row you picked, so each number in the row became a multiplier, 4, 0, and 2. Alright, and there's my 4, my 0, and my 2. Except for the signs. If it was using the middle row, you had to negate, keep, negate. So my 4 became -4, and my 2 became -2 because I had to negate those terms. And you'll recall I got the matrix to do the determinant of by crossing things out. So for example, if I was doing the 2, I crossed out that column and I got the minor matrix by looking at the leftovers. Alright, and then I just figured it out from there, remembering that this is a determinant and a determinant and a determinant. And then I showed you how to find the determinant of a 3x3 matrix using diagonals. We simply recopied the first two columns, and then we did all 3 down diagonals, minus all 3 up diagonals, Now understand that I got these down diagonals and the up diagonals. We are multiplying. Multiply, 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 get those 3 numbers. Multiply, 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 get those 3 numbers. But then you're combining like terms after that. Alright, I hope this has been helpful for you. and I will see you on the next video. It'd be interesting to know which of these two methods you guys prefer. Alright, if you're watching this in 2013, I will probably put a survey up on Edmodo to see how many people prefer cofactor expansion and how many people prefer diagonals. Alright, have a great day.